Now today I'm going to introduce you to a new concept. And to demonstrate, I'm going to ask for two students to assist us. So Soraya, can you assist us please? Just step to the front of the class. And Malcolm, you help us? Now I'm going to give Malcolm and Soraya some instructions, and I want you to listen to the pair of instructions that I'm giving them, and I want you to think about the instructions. So Soraya, can you take 2 steps forward? Malcolm, can you take 2 steps backward? Soraya, 1 step to the left. Malcolm, 1 step to the right. Think about those pair of instructions that I've given to Soraya and Malcolm. What do you notice about those instructions? Opposite. They are opposite instructions. Good. Right, the processes are being reversed. Opposite sequence. Very good. Any other word comes to mind? They are inverses. Very good. Thank you, Soraya and Malcolm. So we noticed that the instructions that I was giving to Soraya and Malcolm are opposite instructions. As we said, they represent a reversal in sequence, a reversal in process. They are the inverse function. Now that is our topic for today's class. We are going to investigate the inverse function. And see if we can develop a definition for exactly what the inverse function is. As we would recall, a function is a relation. Let us review the different types of relations that exist. You should recall that a relation can be a one-to-one mapping. And remember what the one-to-one mapping means? It means that each element in the domain is mapped onto one element in the range. So for instance, this is an example. We already have a symbol that represents the regular function. The inverse function will need its own notation. And the notation that is used to represent the inverse function of f, is written as f minus 1, right, as a superscript, x is equal to x over 2. This notation here represents the inverse of f. Let's work another example. If we have the function f of x is equal to x plus 3, I can represent this on a relation diagram. The relation diagram is going to have my two ovals, one representing my domain, one representing my range, and I can place in some values. So I can place in 2, 3, and 4. What will be the corresponding value of each of these domain values? 5. First here we will add 3. 2 plus 3, 5. 6. 7. So again we have domain, range. Let us manipulate this diagram to determine what the inverse of the function is going to be. The inverse of the function, again, our two ovals, our values 5, 6, and 7 will now represent our domain values. The values 2, 3, and 4 will represent our range. and the direction of the arrow will be moving from right to left. What will be the operation that takes us from the domain to range? We will be minusing 3. Therefore, the inverse function, which will be written as f inverse x, is equal to x minus 3. Do you have any questions?
Yes. So if you're looking at like add
Yes.
after the second part, or they're asking you that any question?
If they're asking you, the question will provide you with the function. And of course, once you are provided with the function, you will be able to create your initial relation diagram. You will then need to manipulate the relation diagram in order to determine the inverse of the function. And we realize that in the manipulation, we need to exchange the domain and the range, and we need to change the directions of the arrows. Changing the direction of the arrow means that the operation itself will also be reversed, because we already established that the inverse is a reversal and it's the opposite. So if we were adding 3 before, we will now have to minus 3 to determine what the inverse is. And using our new notation for representing the inverse of a function, we can represent exactly what the inverse of a function is. So for this example, I will have f minus 1x is equal to x minus 3. Are there any other questions? Yes?
Do you have any other symbols that you could use?
Yes. Well, we learned when we did functions that we normally use a common letter to name our function. So we have the f function. Common letters that I use can also be G, H, K, but they can use any letter. So if I have a function g of x, then the inverse of this function will be written as g inverse x. If my function was h of x, then the inverse of the function will be h inverse x. So any symbol or any letter really can be used to represent our function, and we can find the corresponding notation for the inverse. So let's quickly review what we have learned. So we are going to proceed to an activity. I want you to arrange yourselves in groups. Right, in groups of about 3, I will assist you. So Onika, can you join Khadija to the front of the class, please? And Onika, Khadija, Saraya, and Shalini will form the first group. So Onika, can you collect material for your group? Each group has a different activity. I want you to work on it quickly. Alright, so have you finished the exercise?
Yes.
Okay, well, we are going to get presenters from each group to display their solutions. So we'll start with the group in the back. Michael, can you present the solutions for your group? Let's take a look at the first question. Great.
Well, first, we put in the values 1, 2, 3 to make up x values, and we use the operation multiplied by 1 and minus 1, you got 2.
So multiplied by 1?
I mean multiplied by 3 and minus 1, you got 2.
Good.
2 by 3, 6, minus 1, 5. To find the inverse, we change the domains using the same values, change the domain and the range, and reverse the operation.
Good. So the inverse function is?
X plus 1 divided by 3.
X plus 1 divided by 3. Alright, so based on what we have learned today, I have organized some questions that you can try for home lesson. Alright, so this was a very interesting lesson. And what we have learned, or what you have learned, is that a very productive class. Next class, I'm going to introduce you to the flowchart, and we're going to see how we can derive expressions for the inverse of the function. So, have a good day, and I'll see you all next class.
Thank you. Bye.